By Jonathan Amos, BBC Science correspondent. Media playback is unsupported on your device. Media caption and animation depicts changes in atmospheric CO2 through the year. A NASA satellite has provided remarkable new insights on how CO2 is moved through the Earth's atmosphere. The Orbiting Carbon Observatory (OCO) tracked the behavior of the gas in 20,152,016, a period when the planet experienced a major El Niño event. This climate phenomenon boosts the amount of CO2 in the air. The U.S. Space Agency's OCO satellite was able to show how that increase was controlled by the response of tropical forests to heat and drought. The forest's ability to draw down carbon dioxide, some of it produced by human activity, was severely curtailed. The science has significant implications because the kind of conditions associated with El Niños are expected to become much more common under global warming. If future climate is more like this recent El Niño, the trouble is the Earth may actually lose some of the carbon removal services we get from these tropical forests, and then CO2 will increase even faster in the atmosphere, explained Scott Denning, an OCO science team member from Colorado State University in Fort Collins. That would amplify warming, he told reporters. Image caption: The mission is the subject of a big spread in this week's edition of the journal Science. Technical papers describing OCO's work have just been published in Science magazine. El Niños occur when warm waters in the western Pacific periodically shift eastwards. This sets off a global perturbation in weather systems, redistributing rainfall and bumping up temperatures. The 201,516 event was one of the strongest on record, and this was evident in the rise of CO2. Normally, the concentration of the gas in the atmosphere goes up each year by about 2 parts per million by volume ppm of air molecules, the equivalent of 4 gigatons of extra CO2. The current total is just over 400 ppmv. But in this extraordinary El Niño period, the jump was 3 ppmv per year or 6 gigatons. It is a rate of increase not seen on Earth in at least 2,000 years. Image caption: Helicopters in Indonesia, water bombing areas on fire in 2015. What was remarkable, however, was that human emissions of carbon dioxide were thought to have been relatively static over the same period, meaning something strikingly went wrong with the processes that would normally scrub CO2 from the atmosphere. OCO's ability to track the gas and sense the rate of photosynthesis in plants provided the answers. In South America, it could show that the biggest drought in 30 years limited vegetation's ability to consume CO2. In Africa, hotter-than-average temperatures increased decomposition of plant material, releasing carbon dioxide into the atmosphere. And in Asia, tinder-dry conditions fed rampant fires, particularly in Indonesia. The fires released peat carbon that had accumulated over thousands of years, said Junji Liu, an OCO research scientist at NASA's Jet Propulsion Laboratory. This is the gold star for OCO. We wanted to understand what happened in different regions of the world, said NASA Deputy Project Scientist Anne-Marie Eldering. We used to think of the tropics in a monolithic way, but now we can say one region behaved this way and another region behaved in a different way, and together they created this effect of more carbon in the atmosphere, she told this week's Science in Action program on the BBC World Service. Image caption: Artwork. The Orbiting Carbon Observatory was launched in 2014. Paul Palmer, an atmospheric scientist at Edinburgh University in the UK, described the OCO observations as groundbreaking. This is the first major climate variation where we've had satellite observations of atmospheric composition, and of land properties and of ocean properties all at the same time, he said. The last major El Niño was 19,978, and that was really just the start of the satellite tropospheric chemistry missions. We're now sampling a lot of different variables, and the real breakthrough comes when you tie all the information together. We're not quite there yet, but this is a really good start. Image caption: Building up a picture of CO2 is a complex business that requires a lot of modeling. The Orbiting Carbon Observatory is described as a pathfinder for the types of carbon monitoring satellites that will come later. OCO is very accurate in its measurements, but it only sees a very narrow swath 10 kilometers wide of the Earth when it flies overhead. Europe is planning a constellation of satellites called Sentinel-7 that will map CO2 over a much wider area, but still at very high precision. S7 will trace in much more detail the sources and sinks of carbon dioxide. This orbiting network would even make it possible to police individual countries' commitments to reduce carbon emissions under international agreements such as the Paris Climate Accord of 2015. Jonathan Amos, internet at bbc.co.uk, and follow me on Twitter at bbcamos.